Hello, my dear students. So, this is a neat chemical bonding level 1 type of questions. Already, we have discussed 100 questions in this, and we are going to discuss the third part. From 101st question, we are going to discuss. So, already, ரெண்டு வீடியோ இதுக்காக நம்ம ஷேர் பண்ணியிருக்கோம். We have discussed nearly 100 questions. So, I will go for the 101st question. Yeah. Which of the following contains coordinate and as well as covalent bonds? Look at this compound N2H5 plus. So this is nothing but hydrazine's version. NH2, NH2. This is hydrazine. Sorry, in which it is having two lone pairs. If a H plus comes here, nothing but this nitrogen will donate the electron to H plus, and this nitrogen will become positive. This is nothing but N2H5 plus. Then think of this molecule, water, nothing but water. Okay, if H plus comes from somewhere, this oxygen will donate a pair of electron and this will become positive. This is nothing but hydronium ion. This is called as hydronium ion. It's 3 plus. So there are covalent bonds in this molecule and in this molecule. Whereas HCl contains no coordinate bond. Coordinate bond. This is one bond, coordinate bond. And there is no coordinate in water. So the answer, the exact answer for this is option A and B. The correct answer is B. 102. Next question. 102. In coordinate bond, the acceptor atom must essentially contain, so B is the donor atom, A is the acceptor atom. It must contain an empty orbital to accept a pair of electron given from the donor. So it should contain in its valence shell an orbital with no electron. Empty orbital should be there. So the answer is no, with no electron. Then question number 103. The number of sigma bonds and pi bonds in C2CN4. So there are 2 carbons and 4 cyanides. This is a cyanide. This is another cyanide. This is third cyanide. This is fourth cyanide. Carbon should contain 4 bonds, one above and one below. So the third and fourth bond. So now I will go for calculating part. Sigma, 1 sigma, second sigma, third sigma, fourth sigma, fifth sigma, sixth one, seventh one, eighth one, ninth one. So there are 9 sigma bonds. I'll go for the pi bonds. Here there are 1 pi bond, second pi bond, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one. So there are 9 sigma bonds and 9 pi bonds. So the answer is option A. Question number 4. The non-directional orbital is, as you know, exactly s orbital. S orbital is spherically symmetrical. It is spherically symmetrical about all the axes. So it is not having any specific direction. It is non-directional. Then the type of bonds between 2 electronegative atoms. Example, chlorine is an electronegative atom, chlorine is another electronegative atom. Both of them are electronegative, means they will share the electron. So the type of bond formed between them will be definitely covalent bond, a covalent bond. Right, next, linear combination of 2 hybridized orbitals belonging to 2 atoms and each having 1 electron. So listen carefully. This is a hybridized orbital of one person, and this is another hybridized orbital of another person. They are each are having 1 electron. That means they will exactly collide with each other and they will form a sigma bond, single bond. They will form a single bond. That single bond is called as what bond? Sigma bond. They will not form a double bond. They will not form a coordinate bond. They will not form a double bond, pi bond. So the exact answer for the question is only option A. 107. In FeCO5, the hybridized state and the number of coordinate bonds. See here, iron. Right. So iron is accepting 5 pairs of electrons from CO. Iron is accepting 5 pairs of electrons. So it should be sp3d or dsp3, which is exactly correct. Right. So FeCO5 iron 26 electrons 4s2 3d6 4b0. Right. So iron is combining with CO. CO is we will see this in coordination compounds, but it is a very strong field ligand. So what happens now? Look here. This is s orbital. When drawing the molecular VV theory diagram for coordination compounds, we used to draw like this. Pain mistake. Yeah, I have the eraser now. In my last video, I am not able to erase the things. Yeah. Okay. So it is 3d6 4s2 4p0. Listen, these 8 electrons, since this fellow is a very strong field ligand, they will be packed within 4 rooms. 1 pair, second pair, third pair, fourth pair. That means 8 electrons. Now CO will give a pair of electrons here. Second pair, third, fourth, fifth. So the hybridization is, this one is d orbital, s orbital and 3p orbital. So the hybridization is exactly dsp3. dsp3. So very simple. Hybridization is dsp3 and 5 CO means 5 pairs of electrons. That means 10 electrons are accepted. 10 electrons are accepted. 108. In protonation of water, the changes occurring are, see here, this is water. Protonation means addition of H plus. If you add a H plus molecule, oxygen will become like this. So here there are 2 bond pairs, 2 lone pair. Here there are 3 bond pair, 1 lone pair. This is bent shape. This is pyramidal in shape. Pyramidal in shape. Totally 4 pairs, that means sp3 hybridization. Totally 4 pairs, that means sp3 hybridization. Now you look at the question and answer it. So 108th question. The hybridization state changes are no. Both it is sp3. Shape of the molecule changes are yes. Yes, the shape changes from bent shape to pyramidal shape. Bent shape to pyramidal shape. Very good. 109. The orbitals, d orbital, which is involved in sp3d. If they mean only one d orbital, in general, since the internuclear axis is taken as z axis, this d orbital will be dz square orbital. Dz square orbital. 110. In this compound, the C2C3 bond is formed with the overlapping of, this is the second carbon which is having one pi bond. That means this is a sp2 carbon. And this is the third carbon which does not have any pi bond. That means it is sp3 carbon. So the bond is formed between sp2 and sp3 carbons. 111. In sp3 orbital, so sp3 in total there are 1 plus 3, 4 orbitals. So 75% is p character and 25% is s character. So this is wrong, this is wrong. 70% is p character. Option C is correct. So for 111, option C is correct. It is 75% in total. See here pa, 3%, 3 times p character and 1 time is s character. So the percentage of p is equal to 3 in total divided by total 1 is 3 plus 1 is 4 into 100. So it is 75%, that is 3 by 4 percentage. 3 by 4 percentage. Then question number 112. In which of the following hybridization state different quantum numbers are used? Different quantum numbers are used. Okay. So let us go for sp3d3. So if sp3d3 means it will be of ns orbital, the same np orbital and the same nd orbital. Second option sp3d, the same ns orbital, np orbital and nd orbital. If it is d2sp3 means, listen carefully, this will be nth s orbital and this will be nth p orbital, whereas this d will be n minus 1 inertial d orbital. So here a different quantum number, a different principal quantum number is used. So the answer is option C. Next, which of the following set of species have same hybridization but differ in their shape. Okay, let us look up the hybridization part. NO2 plus NO2 NO2 minus. Yeah, you know the formula, right? Hybridization is equal to half into valence electron plus monovalent electron plus or minus charge. 4 by 2 it is 2. Half into valence electron plus monovalent electron plus or minus charge, it is 2.5. Yeah, I will explain you. Half into valence electron plus some monovalent electron plus or minus charge, it is also 2.5. Leave it. Enna here, in case of nitrogen and its compound, this is structure 1. So 2 bond pair this side and that side, it is sp hybridization. Whereas the remaining 2 belong to sp2 category. 2.5 doesn't mean here, or the formula will not be working out in all the cases, right? Here we have to consider that single electron also in case of NO2. In case of NO2 minus, you have to think of it as a lone pair. Then you have to add an electron here, right? Here. In case of NO2 minus, I made a mistake. Listen carefully. In case of NO2 minus, you have to add an electron because there is a negative charge, means an extra electron. So 6 by 2 it is 3. 6 by 2 it is 3. So they are having different hybridization. Come here, option B, ClO4 minus SF4 XeF4. Sir, hybridization half into valence electron plus mono electron plus or minus charge 8 by 4. Sir, 8 by 2 4. 4 means sp3. Half into valence electron plus mono electron plus or minus 10 by 2 5. 5 means sp3. Sir, D sp3D, different hybridization. They are not same hybridization. So A is not your answer, B is not your answer. I am going for C. NH4 plus H3O plus OF2. Half into valence electron plus mono electron plus or minus charge 8 by 2 4. Half into valence electron plus mono electron plus or minus charge. So 8 by 2 4. Half into valence electron plus mono electron plus or minus charge 8 by 2 4. So yeah, sir, everybody is sp3. All the 3 are sp3. And what about the structure? 4 bond pair tetrahedral, sir. 3 bond pair, 1 lone pair pyramidal, sir. 2 bond pair plus 2 lone pair, sir. Bent shape or V shape, yeah. So the answer is option C. They are having the same hybridization, but all of them are having different shapes. Question number 114. Which of the following elements cannot exhibit sp3d? If they want to exhibit sp3d, they need what orbital? D orbital. Carbon, boron does not have empty d orbital. So the sp3d state can be exhibited by phosphorus and chlorine. B and C. The answer is option C. Option C. So they are asking which cannot. That means it is not option C. A cannot exhibit and D cannot exhibit. So the answer is option B. A and D cannot exhibit sp3d. 115. Which of the following starred carbon is sp3 hybridized? sp3 hybridized. Look here. First one, HCOOH. On looking itself, we can easily say it is sp2. Second one, NH2, NH2. You can easily say it is sp2. Third one, CH3, CH3, HOH. It is sp3. So carbon is having 4 sigma bonds. 4 sigma bonds, sp3. So the answer for the question is option C. 116. A molecule is square planar with no lone pair. No lone pair. But it is square planar. Right. That means it involves an inner d orbital. That means it will involve an inner d orbital. Why? Because according to VSEPR theory, square planar geometry is square planar structure is held by 4 bond pair and 2 lone pair. That means in total 6 pairs should be there. That is sp3 d2 or d2 sp3. Whereas here there are no lone pair means only 4 bond pairs. Only 4 bond pair means it should be a dsp2 hybridized orbital. It should be a dsp2 hybridized orbital. Very good. Then question number 117. In which of the following compounds there is only one kind of hybridization for carbon? So here in first, everybody is single bonded carbon, all are sp3 carbons. All are sp3 carbons. In second, these two carbons are having double bond, sp2. So whereas the remaining two carbons are sp3. In third, everybody is having double bond, all are sp2 carbons. So the answer for the question is A, C. And in D also, there are only two carbons and it is also sp, it is also sp. So more than one kind they are asking. Then it is B only. So the answer is B only. So in option A, here all are sp3, here all are sp2, here all are sp. I am speaking about carbon alone. Carbon பத்தி மட்டும் பேசுறேன். Next 118. Hybridization state of iodine in this compound. What is the formula for hybridization? Half into valence electron plus monovalent atoms plus or minus charge. So it is 8 by 2. 8 by 2 means sp3. So the answer is option C. 118 is option C. 119. The hybridized state of central atom in diborane. Diborane is B2H6. Diamond is nothing but carbon. Graphite. Listen. Diamond is pakka tetrahedral, pakka sp3. Graphite is sheet-like structures. We know there is a free electron. So leave that free electron. Remaining 3 electrons are used for bonding. 3 sigma bonds means 3 sigma. Here the carbon forms 4 sigma bonds in diamond. A carbon forms 3 sigma bonds in graphite. Coming for B2H6. Look here. This is BH3 and this is another BH3. These two electrons are shifted here also. Similarly, these two electrons are shifted here also. You might have studied this. This is called as 3-centered 2-electron bond or banana bond. Banana bond. So, since this is like resonance, there is always 1, 2, 3 and fourth pair around a boron. Boron has 4 pairs. 4 pairs means what is hybridization? sp3. So the answer is sp3, sp3 and sp2. Boy. sp3, sp3 and sp2. Right. They have given some compounds. The covalent bond character. So all of them are attached to Cl minus. So lithium plus, beryllium 2 plus, boron 3 plus, carbon 4 plus. So who will more polarize the Cl minus ion? Sir, carbon will more polarize it. So since this is having a greater charge, carbon will produce more polarization. So the most covalent compound is carbon. The answer is 2 or 3. And the least one is lithium among the given option. So the answer is option C. 121. Molecular orbital theory. Valential electronic configuration of an ion. Okay. The bond order. Bond order is nothing but half into Nb minus Na. So these sigma and sigma star is not printed. Okay, leave it. These two will cancel each other. So I'll go for the remaining thing. This is pi 2px 2 electron and pi 2p. Y is also having 2 electrons. This is sigma 2pz. So 6 electrons in bonding molecular state and 1 electron in anti-bonding molecular state. So 5 by 2, 2.5 is your answer. Option D. 121. It is option D. Listen carefully. We are planning for nitrogen. So nitrogen, I'll do it. I don't know how many electrons are there because it is an ion. So this is the diagram for nitrogen. What they have given. I'll draw this. I'll draw this first. Look at the diagram carefully. Pi 2p4. 4 means 1, 2, 3, 4. This is what it is mentioned. This is, I'm drawing this. 1, 2. And now I am drawing this. It is only 1 present on the top. So it is 6 minus 1. That is why it is 6 minus 1. So the answer is 2.5. Next. 122. Which of the following group of molecules will have 2.5 bond order? 2.5. Okay. Right. Listen carefully. There are a lot of tricks available to understand, but in general, you just keep in mind the two diagrams up to nitrogen. The diagram will be like this, After nitrogen, that means from oxygen, the diagram will be like this. You know that very well. You just keep this in mind. Okay, right. And first one, I'll go for N22 minus. Sir, nitrogen means 2p3, 6 electrons. 1, 2, 3, 4, 5, 6. So, this is N2. But they have given N2 minus. That means 2 additional electrons. That means half into 6 minus 2. 4 by 2. That means 2. Bond order is 2. So, this is not your answer. So, you directly go for option B, N2 plus. Sir, again look. I am going to erase those 2 electrons drawn here. Sir, this is the diagram of N2. They have given plus means I am removing this electron. So, the bond order for N2 plus is half into 5 minus 0. It is 2.5. This may be your answer. Now, I'll check for O2 plus, second one. O2 plus. Sir, oxygen. Oxygen means 2p4 and 2p4. This is normal oxygen. 1, 2, 3, 4, 5, 6, 8 electrons are drawn. O2 plus they have given. Plus means remove this 1 electron. So, it is half into 6 minus 1, 5 by 2, 2.5. Now, I am going for NO. Sir, how to draw for NO? You have to think of the left side atom, which is nitrogen, and right side atom oxygen. This is 2p3 and this is 2p4. 7 electrons, you know 6 electrons will be drawn in bonding orbital and the 7th electron will be drawn in antibonding orbital. So, NB minus Na, it is 2.5. So, in option B, all are having a bond order of 2.5. In option B, all are having an order of 2.5. Okay? Right. Unnecessarily, instead of mugging up some tricks, this thing is far better. 123. The molecule having one unpaired electron. So, the molecule which is having one unpaired electron. Very simple. NO. How, sir? Nitrogen is having 5 valence electron. 1, 2, 3, 4, 5th one. Oxygen is having 6. 1, 2, 3, 4, 5, 6. Oxygen is octet, but nitrogen is not. There is a unpaired electron. So, the one having an unpaired electron is NO. Next. The number of anti-bonding electron pairs in O2 minus. I'll draw O2. Sir, O2 should be like this. 1, 2, 3, 4, 5, 6, 7, 8. Minus means there should be another electron. There should be another electron here. So, the number of anti-bonding electron pairs. They are asking pairs. Only one anti-bonding electron pair. Oh, then sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. So, here also they are completely filled, right? So, this is an antibonding pair, this is another antibonding pair, and this is another antibonding pair. So, 3 pairs, 3 antibonding pairs. 125. On the basis of molecular orbital theory, which molecule does not exist? As you very well know, one inert gas will not react with another inert gas. Even you may think of, this may not exist, but I will explain you. Helium is 1s2, hydrogen is 1s1. There are 2 orbitals combined. This is sigma 1s and this is sigma star 1s. In total, there are 3 electrons. 1, 2, 3. Bond order is half into Nb minus Na. That is half, 0.5. Though it is not possible, in rare circumstances, it may be possible. But this is bond order 0. Bond order 0 does not exist. Okay? Maximum bond energy is shown by. What is the relationship between bond order and bond energy? They are directly related. So, the one having a more bond order. I know the bond order for oxygen is 2. Because, as usual, immediately you keep it in mind. This, sir, this is oxygen, sir. So, 6 minus 2, 4 by 2. Right. O2 minus means add an electron. It is now 6 minus 3. 6 minus 3. So, it is 1.5. 2 minus. It is 6 minus 4. 1. This is, yeah, ozone is structure is like this. So it is in between 1 and 2, 1.4, something like that. So this fellow is having the maximum bond order. So the same fellow will be having the maximum bond energy. 127. Which of the following species will have minimum bond energy? Yeah, the same thing. Bond order is directly proportional to bond energy. All of them are nitrogen. Sir, nitrogen diagram will be like this. 2p3, 2p3. Totally 6 electrons, sir. 3, 4, 5, 6. This is N2. So the bond order is 3. Minus means add an electron, sir. 6 minus 1, 5 by 2, 2.5. Minus 2, add another electron, sir. 6 minus 4, 2 by 2. Sorry, 6 minus 2, 4 by 2. 2, sir, bond order. N2 plus, sir. This is N2. Plus means remove an electron here. It is 5 minus 1 by 2. 2. So, the one having lower bond order is the answer, right? Here, N2 plus and N2 2 minus. Both of them are having bond order of 2. Both of them are having bond order of 2. Right. In order to explain this, again I will go for the diagram again. Nitrogen will be like this. First diagram. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is nitrogen. Think of carefully. Plus means I have removed an electron. That means there is no electron in anti-bonding molecular orbital. There is no electron in anti-bonding molecular orbital. Right? 2 minus means there are 2 electrons in anti-bonding molecular orbital. So this is, since there are 2 electrons in anti-bonding molecular orbital, this is so much unstable. Unstable means very weak bond energy. Very weak bond energy. So the most appropriate one for the question is option D. 128. Which of the following has ion has not 2.5? No, there is no 2.5. This is 6 minus 3 by 2. 1.5. So this is the answer. Option A. Then N2 and O2 are converted into monoanions. Then which is correct? Sir, N2 is converted into N2 minus. Here the bond order is 3 because it is 6 by 2. Here it is 6 minus 1 by 2, 2.5. O2 becoming O2 minus. Here the bond order is 2. Whereas here 1.5. Okay. Now think of and answer. Bond order decreases. Bond order decreases. So N bond weakens here. Correct. O2 minus bond order decreases. This is correct. N2 minus is paramagnetic. Yeah, there is an unpaired electron, paramagnetic. So this is incorrect. So the incorrect statement is option B. 129 is option B. 130. N2 and O2 are converted into monoatomic ions. N2 becoming N2 plus. Bond order is 3 and here it is 5 by 2, 2.5. O2 becoming O2 plus. Bond order is 2 and it is 5 by 2, 2.5. Here, first statement. Bond order decreases, so bond weakens. Correct. Bond order increases. Correct. O2 plus. Listen, regarding O. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. Unpaired electrons is 2. Whereas O2 plus means you have to remove one electron, right? Unpaired electron is 1. So the paramagnetism decreases. This is also correct. This is also correct. N2 plus becomes diamagnetic. This is totally wrong because there is a single electron. There will be a single electron. There will be a single electron. Okay. So this is wrong. So the wrong statement is answer D. Question number 131. In a homonuclear molecule, which are the following set of orbitals are degenerate? They are given it is a homonuclear molecule. Homonuclear means O2, N2 like that. In those things we will draw in case of oxygen. In case of oxygen we will draw like this one. These two are degenerate. They are having same energy. They are having same energy. So what are the two orbitals? Pi 2px and pi 2py. Pi 2px and pi 2py. In homonuclear, the two atoms are same means these orbitals are having same energy. These orbitals are having same energy. Incorrect statement. Pi orbital have two nodal plane. Pi orbital have two nodal plane. This is correct. Bond order of H plus HEH na 1s2 1s1. In total there are 3 electrons and they have mentioned HEH plus, that means 2 electron only here. So bond order is equal to half into Nb minus Na. It is 1, but it is given 0.5, so this is wrong. So the incorrect statement is option B. You go for other statements pa. Next, KO2 means ida O2 minus. AlO2 means AlO2 minus, that means aluminum is having 3 positive charges in total. I think there is some mistake. Okay, 1 second pa. Okay. Right, let me explain this. Listen carefully. KO2, AlO2 minus, BaO2, NO2 plus. Okay. This is O2 minus. This is O2 minus having, I will explain that in different way. This is O2 having 2 minus charge because this fellow is having 2 plus charge. So I can say 3 minus charge. Okay. And this is nothing but the positive charges of nitrogen. So in this case oxygen is diamagnetic. There is no unpaired electron. In this case, no unpaired electron. Coming for the remaining 3 cases, here definitely unpaired electron is there because we know oxygen. So here 6 electrons and here 1 and 1, 8 electrons. There is another electron. Another electron means unpaired electron is there, sir. It is paramagnetic. Okay. This is O2 to the power 4 minus. So that means 8 plus 4, 12 electron. That means 6 electrons in bonding and 6 electrons in anti-bonding. 6 electrons in bonding, 6 electrons in anti-bonding. No unpaired electron. 6 electrons in bonding, 4 electrons in anti-bonding. No unpaired electron. So the unpaired electron is present only in first one. Potassium superoxide. It is called as potassium superoxide. 134. The value of bond order in NO plus according to molecular orbital theory. So nitrogen 2p3, oxygen 2p4. So from nitrogen means that should be like this. So 7 electron, but it is given NO plus, that means 6 electron. So 6 electrons are filled here. Here it is 0. So half into Nb minus Na. The answer is 3. Next, 135. The bond order of NO is 2.5, while that of NO plus is 3. Which is true? So bond order is high, bond length is low. For NO plus, bond length is low. So which of the following statement is true? NO plus it is low means NO is greater. So the answer is option B. 136. Which of the following species is diamagnetic in nature? Which is diamagnetic? We have already seen this. Hydrogen, because we know it is 1s1, so it is diamagnetic. Okay, hydrogen. Which of the following molecule ions does not contain unpaired electron. Does not contain unpaired electron. So it is nothing but O2 2 minus. So I'm not going to draw the molecular diagram as you are all very well aware of it. 138. Diamagnetic species are those which contain no unpaired electron. Which among the following is diamagnetic? Just now I saw. We saw. O2 2 minus is diamagnetic. Also, N2 is also diamagnetic. This one alone is not diamagnetic. N2 2 minus is not diamagnetic. Both of them are diamagnetic. In question 138, both of them are diamagnetic. Option 1 and 4, both are diamagnetic. Right, 139. In which of the following ionization process bond order has increased? Bond order has increased. So NO becoming NO plus, O2 becoming O2 plus, N2 becoming N2 plus, C2 becoming C2 plus. Just now we saw in the previous page, NO it is 2.5. NO it is 2.5, it is 3. Bond order has increased. It may be the answer. Wait. It is 2 and it is 6 minus 3, 1.5. No. This is 3 and this is 2.5. No. Carbon. Sir, how to draw the carbon structure? Simple. It is 2p2 for this carbon and 2p2 for this carbon. So totally 4 electron. 1, 2, 3, 4. So bond order is 4 minus 0 by 2. 2. Plus means 3 minus 0. That means 1.5. So in only one case, bond order increases. In only one case, bond order has increased. So that should be your answer. That should be your answer. 140. What type of bond is not present in HNO2? HNO2. O double bond N bond OH. This is called as HNO2. So all are covalent bonds only. All are covalent bonds only. So there is no ionic bond as well as there is no coordinate bond. 141. The hydrogen bond is strongest in which case? Strongest in case of fluorine, because fluorine is the most electronegative atom. So carbon, nitrogen, oxygen, fluorine goes in this way. So this fellow is the most electronegative species and he will form the strongest ionic bond, hydrogen bond. 142. Water boils at a higher temperature than H2S because of the capable of forming hydrogen bonds. Water forms better hydrogen bonds. Intermolecular hydrogen bonds are not present in ethers, whereas they are present in alcohols, they are present in carboxylic acid, they are present in amines also. They are not present in ethers. Ethers are not readily forming hydrogen bonds with each other. 144. In which of the molecule the hydrogen bond is not possible? Not possible. This is structure 1, ammonia. Okay. This lone pair of nitrogen definitely will form hydrogen bond with hydrogen. Form COO minus is forming hydrogen bond with this OH group and this OH group. Ortho group and para group forming hydrogen bond. No, this is the answer. A group in ortho position and para position can never form hydrogen bond with each other because of distance. Okay, right. Next, correct order of volatility of the given compounds. Which compound is most volatile? Here, H, fluorine, chlorine, bromine, iodine. So the hydrogen bonds are very strong in this case because of very small size and more electronegativity. See here, this fluorine will be more negative and this hydrogen will be more positive. So the minus will be having a greater affinity. Okay. So the volatility is very less in the case of HF and very high in the case of HI. So the answer is option C. Okay. 146. Glycerol is more viscous than glycol. Reason: glycerol contains 3 OH group. 3 continuous carbon containing OH group is called as glycerol. Glycol is 2 OH groups in continuous carbons. So more OH group, more hydrogen bonding. More extent of hydrogen bonding will be the answer. Option C. 147. The correct order of volatility. On looking itself, I can easily say the correct order of volatility. Option B, because no. Yeah. Here there are more hydrogen bonding, more intermolecular hydrogen bonding. Here there are more intermolecular. Here there is more intramolecular. I'll draw the diagram and I'll explain you. This is orthonitrophenol and this is paranitrophenol. Since they form a hydrogen bond here, there is no connection between one molecule A and another molecule B. There is no connection between one orthonitrophenol and another orthonitrophenol. So, because of the lack of intermolecular hydrogen bonding, this is called as intramolecular hydrogen bonding, and here intermolecular happens. So, orthonitrophenol is more volatile. 148, maximum extent of hydrogen bonding is shown by which molecule? As I already told you, maximum extent of hydrogen bonding, maximum extent. Here stronger hydrogen bonding is shown, but maximum is shown by water. How, sir? See here. This is one water. This is one water. This is another water. You know this fellow is having two lone pairs. And so, this proton will be attracted by this fellow and this will be by this fellow because he is positively charged and he is also positively charged. So, one oxygen is surrounded tetrahedrally by 4 hydrogens. 2 hydrogens by covalent bond and 2 hydrogens by a hydrogen bond. So, in water, oxygen is tetrahedrally surrounded by 4 hydrogens, 2 by normal covalent bond and 2 by hydrogen bonds. Next, intramolecular hydrogen bond. Yeah, see here, this is intramolecular hydrogen bond. This decreases the boiling point, thereby increases the vapor pressure. Because boiling point and vapor pressure, they are inversely related to each other. So, decreases the boiling point means increases the vapor pressure. 150. The incorrect order for the given thing is decreasing boiling point. Yeah, this fellow is having the greatest boiling point because of hydrogen bonding. This fellow is having the greatest boiling point because of hydrogen bonding. This fellow is having the greatest boiling point because of molecular weight. And so this is the answer. Here, this fellow is having the greatest boiling point because boiling point is directly proportional to molecular weight. Molecular weight increases, the boiling point should be highest for silane. SiH4 should be having the highest. Okay? But not to SiH4, it is germanium, but since it is given as carbon, it is wrong. They are asking which is incorrect order, so the answer is option donkey. Next, incorrect viscosity. This is more viscous because sulfur is having a greater charge. More viscous because of more intermolecular hydrogen bonding. This is wrong. Intermolecular hydrogen bonding alone gives the viscous nature. Intermolecular hydrogen bonding is present in paranitrophenol, so this is wrong. So, the incorrect statement is option C is incorrect. 152. The crystal lattice of ice is mostly formed by. So, what is the maximum bond that exists in ice? In ice, we already told H2O. So, this oxygen is negative charge and hydrogen is positive charge. This is called as dipole force, which is nothing but hydrogen bonds. Intermolecular hydrogen bonds are there. Also, among water, there are 2 covalent bonds. Okay. So, the exact answer is option D. Weakest hydrogen bond is shown by which one? Weakest hydrogen bond is shown by sulfur. Hydrogen bond was introduced by, I don't know who this is. I will refer. Wait. Latimer Rodebush. Option B. 155. Which of the following has the strongest intramolecular hydrogen bonding? So this hydrogen will be having with this one. Here there is no possibility of that much. Para no possibility. Option A. Acetic acid exists as dimer in benzene due to hydrogen bonding. I will explain you how it is. This is acetic acid. this is another acetic acid. In benzene, this oxygen and this hydrogen are formed by hydrogen bond. So it exists just because of two hydrogen bonds. So it exists as dimer because of hydrogen bonding. Okay, so far we have discussed in 3 videos 156 questions in chemical bonding. All of them are level 1 questions. Soon I will put videos for level 2 questions also. Okay, thank you so much.